All right, guys, good morning. So today we are going to continue looking at dimensional analysis, specifically with the metric system. Okay? So our goal for the end of the day is that we will be able to convert between different units using the metric system and dimensional analysis. So we're using that same dimensional analysis that we looked at earlier this week. It's just now that we're looking at a very specific system of measurement. So what is the metric system, you ask? Well, the metric system is going to be a system of measurement, okay? Just like how in the US we have pounds, feet, inches, quarts, the metric system has its own units of measurement depending on what we are measuring. Okay. For instance, if we are measuring time, we're going to use the unit seconds. If we're measuring a length, we're going to use the distance meters. If we're measuring a mass, we're going to use the units of grams. If we're measuring volume, we're going to use the units of liters. And if we are using, or if we are measuring temperature, we are going to use the units of Kelvin. Okay? So depending what we are measuring determines which unit we use to describe our measurement. All right, so let's talk about why we're going to use the metric system. Why use it instead of our standard system that we use in the US? So there are several benefits to using the metric system. So the first one is that we just are working with our base units. So we are just working with seconds, meters, grams, liters, and Kelvin. Instead of having different units of measurement like feet, inches, and miles, the metric system is going to use prefixes to determine the magnitude of the measurement. And these are all based on powers of 10. So not only do we not need to memorize different units, but we also are able to work with powers of 10, which are very easy numbers to work with. So in the metric system, instead of having inches, we have centimeters, where centi is that prefix telling us the size of our measurement, and meters is the unit telling us what exactly we're measuring. Instead of having feet, we just have our base unit of meters. And then instead of miles, we have kilometers. Where again, kilo is that prefix telling us the size of our measurement, and that meters is telling us that we're measuring a distance. Okay, so those prefixes tell us the size of our measurement, whereas that base, that meters, is going to tell us what exactly we are measuring. So if we look at this chart, we can see all the prefixes in our metric system. Okay, and these will tell us the size of our measurement. We can see as we move up from our base, which is at no prefix, our size of our measurement gets larger and larger. Okay? Whereas when we move down, the size of our measurement is getting smaller. Okay? So these are a lot. We are only going to focus on 4 main ones. Okay? So the first one we are going to focus on is kilo. Okay, so this is going to come before our base unit. So we could have kilogram, we could have kilometer, we could have kiloliter, or we could have kilosecond, depending on what exactly you are measuring. Okay? The important thing that we need to know that we are going to have 1,000 things. So 1,000 grams, 1,000 meters, 1,000 liters, or 1,000 seconds for every 1 kilo thing. Okay, so that means if we have 1 kilometer, that means we have 1,000 meters. If we have a kilogram, that means we have 1,000 grams. So since we have this equality here, 1,000 things is the same thing as 1 kilo thing, we can use this as a conversion factor in our dimensional analysis. So depending on what we are trying to cancel out, we can write our fraction as either 1,000 things, where again, that thing is either a gram, meter, liter, or second for every 1 kilo thing. Or we could also write that the other way. Again, it all just determines what we are trying to cancel out. We can say for every 1 kilo thing, so for every 1 let's say kilosecond, we have 1,000 things, or 1,000 seconds. Okay, so this kilo, that is going to tell us our unit is bigger than our base unit. Okay, so a kilometer is bigger than a meter. A kiloliter is bigger than a liter. Okay, when we're thinking about when we would use kilometers in measurements, think about, for instance, a large distance. So when you're going on your road trip, you would measure your distance in kilometers. Because you're traveling more than just a couple meters, you're going to want to use a bigger unit of measurement. So when we're measuring large distances or large volumes, a large amount of time, or large mass, this is when we would use the prefix kilo. That is different than when we would use the prefix centi. Okay, so centi, we probably sounds familiar from like century, centipede. Okay, whenever we see the cent, I want you guys to think of 100, like 100 years in a century, 100 legs on a centipede. Because for centi, whether it's a centigram, a centimeter, a centiliter, or a centisecond, we are going to have 100 centi things for every one thing. Okay, so for every 100 centimeters, we have 1 meter. For every 100 centiseconds, we have 1 second. Okay, so this guy is going to be a smaller unit of measurement because we need more of them to equal one thing. Okay, we need more centimeters to equal 1 meter. Okay? And again, just like what we saw with our prefix kilo, since we have this equality statement here, we can write this as a conversion factor to use in our dimensional analysis. So we can either say, for every 100 centi things, we have 1 thing, or for every 1 thing, so like for every 1 gram, we have 100 centi things, or 100 centigrams. Okay? Since this is a smaller unit of measurement, we are going to use this to measure smaller amounts. So if you see centi, that tells you you're measuring a small amount. For instance, if we're looking at centimeters, we might use centimeters to measure the length of our pencil. Okay? Since our pencil is smaller than 1 meter, we're going to use a smaller unit of measurement. We're going to use our centimeter. Likewise, milli is also going to be a smaller prefix. Okay. However, if we see milli, here we want to think of millennium. Okay. And in a millennium, we have 1,000 years. So milli, that tells us 1,000. We have 1,000 milli things for every one thing. Okay. So we can think of that as we have 1,000 milligrams for every 1 gram, 1,000 millimeters for every 1 meter, 1,000 milliliters for every 1 liter, and 1,000 milliseconds for every 1 second. So we can plug in our base unit in for things depending on what we are measuring. Okay? And again, we can write this as a conversion factor in our dimensional analysis. Because if I have 1,000 millithings, like 1,000 milliliters, that is the exact same thing as saying I have 1 thing. Or this, I have 1 liter. Or again, depending on what I'm trying to cancel out, I could write that as 1 thing over 1,000 millithings. Something I forgot to talk about earlier is each one of these prefixes is also going to have an abbreviation. So if we want to say like milliliter, liters, instead of writing all that out, we can represent milli with a lowercase m. Okay? Likewise, if we want to represent the prefix centi, here we're going to use a lowercase c, and kilo, we're going to use a lowercase k. So, like for kilo, if we have a kilogram, that would be the same thing as kg, where the k tells us that we have kilo and the g tells us we're measuring in grams. Okay. That brings us to a last one of nano. Okay. So for nano, this one is going to be the smallest prefix that we look at. Okay, so this one is also smaller than one thing. So in nano, we are going to need 1 times 10 to the 9th nano things to equal one thing. So we would need 1 times 10 to the 9th nanograms to equal 1 gram, or 1 times 10 to the 9th nanometers to equal 1 meter. Same thing if we're measuring in liters or in seconds. Okay. And again, same thing as before, since we have an equality here, we can use this as a conversion factor. We can say 1 times 10 to the 9th nano things is the same thing as having one thing. Or 1 times 10 to the 9th nanometers is the same thing as 1 meter. Or depending on what we're trying to cancel out, we can say for every one thing or for every 1 meter, we have 1 times 10 to the 9th nanometers or nano things. Okay. When we're looking at nano, here we're going to represent that prefix with the lowercase n. So if we were doing nanometers, we could represent that with nm, where the n tells us that nano and the m tells us meters. Nanometer is going to be a super small unit of measurement. And just to get an idea of how small that is, the proteins are antibodies in your body. So I know with COVID, antibodies are a hot topic right now. The antibodies in your body are the size of 1 nanometer. So this stuff is not visible to the naked eye. Okay, so nano is going to be a super small unit of measurement. Okay, that's telling us we're measuring something very, very small. That we are a little bit familiar with those metric prefixes that we can help to use to create those conversion factors, let's look at an example of what this would actually look like. So let's say we have an adult mouse that has a mass of 0.035 kilograms. Okay, that K tells us our prefix right here is kilo. You want to see how many nanograms does the mouse weigh. Okay, so here we're starting off with 0.035 kilograms. We want to figure out how many nanograms is this equal to. So we are going to start this the same way we would with our dimensional analysis that we looked at earlier this week. So we're going to start with what we're given. We have 0.035 kilograms. We don't want kilograms though. So we need some way of canceling that unit out. Look up at our unit conversions up top. Okay, these are the conversions using our different prefixes, and we want to find one with kilo. So we see looking at these 1 kilo thing. So what that tells us is if I have 1 kilogram, that is the same thing as 1,000 grams. Okay. Notice that I don't have any conversions between kilo and nano. So I need to start off with going to my base unit first. I need to start off with converting to things or to grams first. So if I want kilo to cancel out, if I have it on top here, that means I need it on the bottom of my conversion factor, which means I'm going to write this function as for every 1,000 grams, we have 1 kilogram. Now we have kilograms on top, kilograms on bottom, they cancel out. Now we are left with grams, but we don't want grams, we want nanograms. So we need to see what conversion factor or equality statement do we know with nano, okay? That's going to be this last one right here, okay? We can see that 1 thing or 1 gram is going to be equal to 1 times 10 to the 9th nanograms. So following the same train of thought as we did earlier, if grams is on top of this fraction, that means I need to put it on bottom of this conversion factor so that they cancel out. So I'm going to write this as for every 1 times 10 to the 9th nanograms, I have 1 gram. Now I have grams on top, grams on bottom, they cancel out. All right, so now that we have nanograms, that is the unit that we were looking for. So now we know we're done. So in our calculator, we're going to do the same thing as we did with our dimensional analysis. Multiply by everything on top and divide by everything on bottom. So 0.035 times 1,000 times 1 times 10 to the 9th, all divided by 1. And when we plug this in our calculator, we should get 3.5 times 10 to the 10th nanogram. Okay. And this makes sense because nanogram is a smaller unit, so we are going to need more of them to equal our 0.035 kilograms. All right, so something important to reiterate here is that when you are converting between different prefixes, like going from kilo to nano, you want to make sure you stop at that base unit first. Okay, so since we don't have a conversion going straight from kilo to nano, you want to make sure you stop at grams before going to nano. Okay, so you just kind of have to make that little pit stop along the way using the conversion factors you're given to you. All right, so let's look at an example that's a little different. So in this one, we have the White House has an area of 5,110 meters squared, and we want to see how many kilometers squared this is. Okay, so we are starting with 5,110 meters squared, and we want to figure out how many kilometers squared this is. So right away, we should notice this one is a little different because we have this squared exponent here. Okay, if we have something squared, that's telling us it's the same thing as meters times meters, and we're trying to get to kilometers times kilometers. Okay? So we're going to start off with what we're given. We're going to start with 5,110 meters squared. And again, we're going to think of that as meters times meters. Okay? So we want to cancel out meters, and our goal is to get to kilo. So we're going to look up at our conversions and see if we have a relationship between our thanes and our kilo. And that's going to be this first one right here. That there are 1,000 meters in 1 kilometer. Okay? So if I want meters to cancel out, that means I need to put meters on bottom of my fraction. So I have 1 kilometer over my 1,000 meters. Okay? Notice though how I have 2 meters in my original number, and I only have 1 meter at the bottom of this fraction. So because of that, I'm only able to cancel out 1 of those meters in my unit, because meters squared is the same thing as meters. So if I divide that by meters, I'm still left with meters. So that means I need to do this conversion factor again, because there are 2 meter units that I need to cancel out. So again, I know there's 1,000 meters in 1 kilometer. Okay. Now that I have meters on bottom again, I'm able to cancel out this other guy. Okay. And now I can see I'm going to end up with kilometers times kilometers, which will help me get the kilometers squared. Okay. So the key here for this one is when your units are squared, we need to do that conversion twice to cancel out both of those units. Okay. Same thing as if our units were cubed. Okay, because if we had meters cubed, that means we would have 3 meters up top that we would have to cancel out. And in that case, we would need to do that conversion 3 times to cancel out each one of those meters. Okay, so if you have the exponent, you're going to have to do your conversion multiple times to cancel out both of those units there. Okay. So now that we canceled out meters squared and we're left with kilometers squared, we're able to plug this in our calculator and do 5,110 divided by 1,000 divided by 1,000 again. And we should find this is the same thing as 0.00511 kilometers squared. Okay, and that makes sense because since kilometers is a larger unit, we are going to need less of them to equal our meters squared. Let's look at one more example. So in this type of example, we have 50 kilometers per hour, and we want to figure out how many centimeters per second that is the same thing as. So this one is a little different because what we're starting off with here is a fraction. So when we write our initial number, we're going to write it as just that. We're going to have our 50 kilometers and put that over our 1 hour because hour is in the denominator of this initial fraction. Okay, so we can see here that we have 2 units that we need to convert. I need to get my kilometers to centimeters, but I also need to get my hours into seconds. Okay, so we can pick whichever one we want to start working with first. It does not matter which one you choose. I'm going to choose to convert to centimeters first, or to cancel out my kilometers. So to cancel out my kilometers, I need to go back up to my conversions and see which conversion factor or what equality statement I have with kilo. And again, I can see that I have 1,000 things in 1 kilo thing. So that's like saying I have 1,000 meters in 1 kilometer. Okay, so if I want to cancel my kilometers out, if it's on the top of this fraction, that means I need it in the bottom of my conversion factor. Okay, which means I'm going to write my fraction as 1,000 meters over 1 kilometer. Now I have kilometers on top, kilometers on bottom, they cancel out. Now I'm left with meters as my unit of distance. But I don't want meters, I want centimeters. So I'm going to go back up to my list of conversions. I'm going to see what relationship I have with meters and centimeters. And that is going to be this guy right here. So 1 thing is equal to 1 centi thing. Or I could think of this as 1 meter is the same thing as 100 centimeters. So if I want to cancel out my meters, if it's on top of this fraction, that means I need it on the bottom of this conversion factor. So I'm going to write this as 100 centimeters over 1 meter. Now my meters are able to cancel out, and I'm just left with centimeters, which was my end goal. Okay. Now that I converted my kilometers to centimeters, I need to convert my hours to seconds. So we need to think, what conversion factor do we know between that includes hours that will help get us to seconds? Okay. So we might know that 1 hour is equal to 60 minutes. So if I want to cancel out hours, hours is in the bottom of my original fraction. So that means to cancel it out, I need to put hours on top of my conversion factor. Because if 1 is on top, 1 is on bottom, then they cancel out. So I'm going to write this equality as 1 hour for every 60 minutes. Okay. Now I can see that I'm left with minutes, but I don't want minutes, I want seconds. So we're going to take this one more step because I know for every 1 minute, I have 60 seconds. So if minutes is on bottom of this fraction, that means I need to put minutes on top of my new conversion factor. Because minutes on bottom, minutes on top, they cancel out. So I'm going to write this as 1 minute over 60 seconds. Now I am left with seconds in my denominator, so I know that I am done and ready to plug it in my calculator. So remember, multiply by everything on top. So 50 times 1,000 times 100, and then divide by everything on bottom. So divide by 60 and divide by 60 again, and we should get a final answer of 1,388.89 centimeters per second. Okay? So if you have something where you have two units that you need to convert, make sure that you're converting one at a time. So decide who you want to convert first and focus on that unit. And then once that one is done, then focus on your other one. Okay? I hope this helped. Please let me know if you have any questions.